A dilation is a transformation whose preimage and image are similar, so they're not necessarily congruent. So remember, congruent means same size and same shape. So these are the same shapes, but they're just different sizes. A dilation is an enlargement if the scale factor is greater than 1, and it is a reduction if the scale factor is less than 1. So I can tell that this right here, this little one, is the pre-image because it doesn't have any primes, and the ABCD prime is the image, so it has been enlarged. This time the original one is larger and it shrinks, so it's called the reduction. So down here, describe the dilation. So when you describe the dilation, you need to have a center of dilation and you need to have a scale factor. So the center is going to be an ordered pair. So to do that, what you do is you connect the corresponding vertices. So here's my M, here's my M prime, and I draw a straight line. Here's my J, here's my J prime, I draw a straight line. Here's my K prime, I draw a straight line. Where these come together is called the center. So this one has a center of 0, 0. The scale factor is, write your image down. So remember, your image is going to have your prime. So take one coordinate. I'm going to use this coordinate. So K prime is 3, 0. And K is 6, 0. So if I'm going from K to K prime, what am I doing? So what you're going to want to do is take K prime and divide it by K. So K prime divided by K is 3, 6, which is 1/2. So the scale factor is 1/2. So take your image and divide it by the preimage. So remember, your image has the primes on it and your preimage does not. Example 2. The height of a tractor trailer is 4.2 meters. The scale factor for the model of the truck is 1 to 54. Find the height of the trailer tractor in centimeters. So the scale is 1 to 54. And we know that the height of the tractor trailer is 4.2 meters. This one should say scale. Or this one should read model right here. I bet it's supposed to read model. Okay, so if we know that we have a 1 to 54 scale and our real figure is 42 meters, 4.2 meters. So 4.2 meters is 4,200 centimeters. So if the scale is 1 to 54, this is the larger one. So it's going to be 1 is to 54 as x is to 4,200. So I'm going to set that up over here. 1 is to 54 as x is to 4,200. So what I'm going to do is 4,200 divided by 54. So when I divide it, I get 4,200 divided by 54 is about 78 centimeters. Oops, I put meters, but in centimeters. Okay, a triangle ABC is dilated by a scale factor of 1.5 about the origin. Find the coordinates of the image. So basically what you're going to do, if the scale factor is 1.5, you're going to multiply each one of these by 1.5. So A prime is going to be 6 and then 7.5. B prime is going to be -3 and positive 9. Oops. And then C prime is going to be negative 7.5, and 15. Because I multiplied all of these by 1.5, because that was a scale factor. Okay, then we're also going to use matrices. So if you have a scale factor of 10, it means you're going to write these as a matrix. So remember, you write your x on the top and your y on the bottom. So 4, 5, negative 2, 6, negative 5, 10. And you're going to multiply it by a scale factor of 10. So 10 times this. So in the end, you get 40, 50, negative 20, 60, negative 50, and 100. And then you can write them as, this is A prime, B prime, C prime. And then example 5, find the missing values in the dilation at left. So I want to know HI. So HI is going to be matched up with H prime, I prime. But I need to know the scale factor before I do anything. So looking at these two, I can use HJ and H prime, J prime to figure out the scale factor. So remember, to figure out the scale factor, you need to take the image and divide it by the pre-image. So 6 divided by 24 is 1/4. So the scale factor is 1/4. So if I have HI and H prime, I prime, this right here has to be 1/4 of the original side. So I'm going to take this and multiply it by 4 and get 32. So I prime and J prime right here, I'll change color here. I prime, J prime is going to be smaller because the scale factor is 1/4. So you're going to take 30 and multiply it by 1/4. So it's 7.5 feet. And then the last, or if a rectangle's dimensions are doubled, what happens to the perimeter? So if you have this width, length, and you double it, so now you have 2 width, 2 length. What happens is this perimeter right here is 2L plus 2W. This perimeter is 4L plus 4W, because perimeter is the distance around. So to go from 2L to 2W, you double it, so the perimeter is doubled. So now let's look at area. So if you have length and width, the area of this is length and width, LW. Then if you have 2 length, 2 width, the area of this is 4LW. So to go from LW to 4LW, you quadruple. And then down here, below is the image after a dilation of 0.4 about the origin. Write the coordinates of the pre-image. So this time we know what the image is, but we don't know the original one. So these are all primes technically. So to figure out if we know that 0.4 is a scale factor, so Q prime divided by Q has to equal 0.4. So if Q prime is 3, 3 divided by Q has to equal 0.4. Solve for Q. So it's going to be, multiply both sides by Q. So it's going to be 3 divided by 0.4 is Q. So I'm going to do 3 divided by 0.4, and I get 7.5. So Q is at 7.5. So way up here, 7.5. So you need to do that for each one of them. Remember, you do the image divided by the pre-image.